Hello there, I am Dr. C.N. Okolubo. You're welcome to my YouTube channel where we'll be solving problems relating to business mathematics, business statistics, analysis for business decision, as well as other related topics. I want to encourage you as you go through these videos with me, you have your paper, your pen, and your calculator to solve these problems with me. Also, please do like, share, and subscribe so that you can receive notifications for upcoming videos that we'll be uploading. Thank you. Hello there, thank you for joining me in this lecture series. Today we are going to start about 3 lectures on calculating mode of group data. In an earlier video, we looked at how to derive the formula of the mode for group data. So in today's lecture, we are going to look at the first in the series of an example of how we can calculate mode of group data. Please follow me and see what we have on our whiteboard. Here we have the first example, and we have the group, the age group 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, and the frequency given. What we need to calculate mode is to first of all identify the modal class. And the modal class is the class with the highest frequency. And looking at this table, which class has the highest frequency? Of course, this one. This class is the class with the highest frequency. So 40 to 49 having the highest frequency of 7 becomes the modal class. So from here, I'm going to write modal class is 40 to 49. Now for us to calculate the mode of the modal class, all we need to identify are the frequency of the modal class, the frequency of the class before the modal class, the 6, and the frequency of the class after the modal class, 7. That's what we need. So look at the formula here. The formula is given as the lower class boundary of the modal class, that's a sign, plus, and I'm opening a brace here. Here we're going to have frequency of the modal class minus frequency of the class before the modal class, divided by frequency of the modal class minus frequency of the class before the modal class, plus frequency of the modal class minus frequency of the class after the modal class, and then multiply by the class size. Multiply by the class size. So let's now plug in these values. So the lower class boundary of the modal class, since we have identified 40 to 49 as the modal class, the lower class boundary will be 39.5. How do you get 39.5 again? It's going to be the lower class limit minus 0.5. The lower class limit of the modal class minus 0.5. So we're going to, so this will be 39.5 plus, we'll open the bracket here. So the frequency of the modal class is 7, and the frequency of the class before the modal class is 6, minus 6, divided by frequency of the modal class is 7 minus frequency of the class before the modal class, that is minus 6, plus frequency of the modal class minus frequency of the class after the modal class. This is 1. 1 here. Then close the bracket times the class size here is what? The class size is 10. 20 to 29 gives us 10. The number of elements in the class gives us 10. So class size is 10. So let's solve this. This is 39.5 plus 7 minus 1, by the point minus 6 is 1, divided by 7 minus 6 is 1 plus 7 minus 1 is 6 times 10. this becomes 39.5 plus 1 over 7 times 10. And we can continue with this. 1 over 7, what would that give us? That will give us 0.1428 times 10. So let's deal with this. Let's deal with this times this. This will give us 39.5 plus 1.428. And if you have 39.5 plus 1.428, that will give us 40.928. So approximately 40.9. So the mode of this class, the modal value for this class is 40.9. Maybe you can write approximately 41, but 40.9 precisely is the modal class. Thank you very much for joining me in this video. If you need more explanation on how to derive this formula, I will kindly advise you check the other video on deriving the modal, the formula for mode for group data. Thank you once again for joining me on this video. If you have not subscribed, please subscribe, like, and share this video. God bless you.